Hello everyone, welcome to your 16th C++ Qt game tutorial. So in this tutorial, hopefully we're going to wrap up the tower defense game and maybe start working on another game in the next tutorial. There's a couple of things that I want to do. First of all, I want to go inside the enemy class and I want to require the client of my code or whoever's using my code, I want to require them to pass in a list of points for the enemy to follow, because an enemy is really nothing without a list of points to follow. So I'm going to enforce that in the constructor. So let's go ahead and change the signature of this constructor and have it require as a first parameter before taking in a parent. We're going to require QList of QPointF. We're going to call it points to follow. Okay, let's go ahead and change this also in the implementation. Okay, and then whereas before in the constructor we just put in some random points, we're gonna just change that to the new list of points that we pass into the constructor. Okay, and then all of this is still the same. Okay, so the second thing that I want to do is give the game class the ability to spawn enemies. Right now, the only way that we can create it is go inside its constructor, create an enemy, set it up, etc. But I want to create one method that does all of that, so that if in the future I want to create new enemies, it would be as easy as calling a method. So basically, in order to do that, first of all, we need to keep track of a few things. So let's go ahead and give the game class a few attributes. We're going to need to give the game class a Q timer, and this timer will be responsible for spawning enemies. Now the reason why we need a timer when spawning enemies is that if we didn't use a timer, let's say you wanted to spawn 5 enemies and you spawn them in the same location, they'll all be stacked, and as they move, they will move together. So all 5 of those enemies will look like just one enemy. This just looks bad. So what I want to do is I want to use a Q timer to spawn one enemy, wait a second, spawn another enemy, wait a second, spawn another enemy. That way the enemies will be in a sort of like a line, because by the time the next enemy spawns, the previous enemy will have already moved a little bit up. So let's go ahead and give the game class a Q timer. We'll call it spawn timer. And then also we need to keep track of how many enemies we've spawned. So enemies spawned. And then we need to keep track of what is the maximum number of enemies that we can spawn. So max number of enemies. Alright, and the last thing that we want to keep track is the list of points for the enemies to follow. So QList of QPointF, and we're going to call this points to follow. Okay, let's go ahead and initialize all of these variables inside the constructor. So right over here, I guess we'll initialize it. So we're going to first of all initialize the timer. We're going to make the game class the parent, and then we're going to initialize enemies spawned to 0 and max number of enemies to 0. Initially, we just want to give everything a value, because remember that in C++ primitives are not initialized by default. You have to initialize them yourself in order to save some unpredictable headaches. Okay, so now let's also initialize our points to follow. So points to follow, we're going to put in a few points. Remember that you can use the stream operator to put items inside a Q list, and this points to follow is a Q list of QPointFs. So let's go ahead and use the stream operator to put a bunch of QPointFs inside it. So QPointF, and basically I want the enemies to start at the top right hand of the screen, so 800 0. Then I want them to move to, like, I don't know, 450 of QPointF, 450, 450, okay? And then I want them to move to the bottom left hand of the screen, which would be 0 on the X and 600 on the Y. Okay, so we're done with our initialization. Let's go ahead and go back inside the game class. And now let's go ahead and create a method for actually creating enemies. So we're going to call it create enemies, sure enough. And we're going to take in an integer that represents the number of enemies that you want to create. So number of enemies. Okay, so basically the goal is that the client or the user will call this method and they will pass in a number of enemies that they want spawned. And then this method will connect this timer to another method, and that method will actually create a single enemy. So we have to give this game class a slot. So let's go ahead and give it the QObject macro. Remember that any class that needs to handle signals and slots must either directly or indirectly inherit from a QObject, which it does, and it must have the QObject macro. So let's go ahead and define a new slot, public slots. We're going to call this slot spawn enemy. And this one will spawn a single enemy, and it won't take any parameters. Okay, so let's go ahead and define this create enemies first of all. So refactor, add definition. Alright, so the first thing that we want to do is set the enemy spawn to 0. So far we have spawned nothing. And then we want to set the max number of enemies that we can spawn to the number of enemies that were passed into this function. Number of enemies, okay. And then we actually want to connect the game's spawn timer to the public slot spawn enemy, because that will be the member that will actually spawn an enemy. So we're going to use connect and then spawn timers signal, the timeout signal, to this game class's slot, which slot, spawn enemy. Okay, there we go. Now let's go ahead and start the spawn timer. And we're going to run it every 1 second or 1000 milliseconds. Okay, so let's go ahead and go back inside the game class, and now let's define the spawn enemy. Oh, refactor, define. There we go. Okay. I don't know why this happened. Let's just make this look nice. Uh-oh. Okay, there we go. So basically what we want to do in this member function is spawn a single enemy. Getting some weird bugs. Okay, so spawn an enemy. We're going to create an enemy first of all. Remember that we forced the user to send in a parameter into the constructor of the enemy. We want them to send in the points that this enemy should follow. So we're simply going to pass in the points to follow, which we initialized inside the constructor of the game class. Okay, good enough. So now we want to set the position of this enemy to be the first point in this points to follow list, 0th, because we want them to start at the 0th point. And then we want to add this enemy to the scene. Remember that you always have to add QGraphics items to scenes in order to visualize them. So enemy. Okay, there we go. And then we want to basically increase our enemies spawned plus equals 1, so that we know we've spawned one enemy. And you guys will know just right now why that's useful. So now after we increase our enemy spawn, we want to check if enemies spawned is greater than or equal to max number of enemies. So this one. If so, we've spawned enough enemies, so we want to stop calling this function. And the way that you do that is, well, basically, first of all, you know that you can connect queue timers to slots, which is basically another way of saying you can connect queue timers to methods of classes. But you can also disconnect queue timers from methods using the QTimers disconnect member function. You can disconnect it from specific methods, or you can just simply disconnect it from everything. Since our spawn timer is only connected to one method, we'll simply call the generic disconnect method to disconnect it from everything. So we'll just do spawn timer, and we'll do disconnect. There we go. So that means if we've spawned enough enemies, stop spawning, because remember that this is connected to a queue timer, so we have to disconnect it. Until this create enemies member function gets called again, then it will be reconnected. So I hope you're seeing the logic in that. Okay, everything looks good here. Let's go ahead and go inside the game class and let's create a few enemies to test this out. So right after we initialize our variables, we're going to create some enemies using create enemies, our newly created member function. Let's create 5 and let's run it. Okay, let's see. Okay, the reason why we're getting this unresolved external symbol is because we added a new Q object. Remember the game class, we just newly added the ability for it to handle signals and slots. Anytime you do that, you got to go to build, clean all, build, run QMake, and then run it again, and that should take care of it. Okay, there we go. And as you can see, our enemies spawn 1 second after each other, so they're nice and spaced out in a line like this, and they're following their points. Now the next thing that I want to do is draw a physical road, because the player needs to know where these enemies are going to travel to. Right now you can't see. So basically, we're going to use a QGraphicsLineItem. Anytime you want to draw an actual line onto a scene, you use a QGraphicsLineItem. Okay, so we're gonna go ahead inside the game class, and I'm gonna encapsulate the drawing of the roads in a member function. So I'll call it create road. Easy enough. Let's go ahead and define what this create road does. And the plan of attack here is to traverse through the list of points. Recall that the game class has a list of points for every enemy to follow. We're going to traverse through that list of points, and we're going to connect each point with its next point via a line that we're going to draw. So when you see the code, this will make a little bit better sense. So let's do for size ti is equal to 0, n is equal to points to follow that size. Okay, and then we subtract 1 because we only want to go up to the second to last point. We're going to connect the second to last point to the last point, but we're not going to connect the last point to anything. So that's why the -1 is here. So then we'll do while I is less than n, I plus plus, just like your typical for loop. Okay. Now let's go ahead and we want to create a line. So let's create a line. A non-physical line first of all. So create a line connecting the 2 points. Okay, Q line F, we're just going to call it line, and it will basically connect points to follow the ith point and the I plus 1. So the current point and the next point will be connected via line. Now remember that the Q line F is not a visible line. It's just a line that you can use to do calculations and such. If you want to actually visualize a line onto a scene, you have to use a QGraphicsLineItem. So it's very easy. You just do Q. First of all, let's go ahead and include it. So include QGraphics. Oh man, QGraphicsLineItem. Okay. So let's go ahead and make one. QGraphicsLineItem, we're going to call it lineItem, new QGraphicsLineItem, and inside the constructor we're going to pass in our non-physical line because the QGraphicsLineItem needs a line. It will just visualize that line basically. Okay, so we've created a line, the line that connects the current and the next point, and then this is a very plain blank line. I want to kind of spice it up a little bit by maybe changing the color and the thickness so it looks a little bit more like a road, a very primitive road. It's still better than just a regular thin line. So basically remember that every object that you draw onto a scene has a pen and a brush, and you can change these pens and brush to make it look different. Remember this graphic from an earlier tutorial. So whenever you draw something, the pen determines the outline style, so you can have all of these different types of pens, and then the brush determines its fill style. So right now we're going to change the pen of this line, because a line doesn't really have a brush, it's just an outline. So let's go ahead and create a new pen, QPen, we're just going to call it pen, and then we'll do pen.setWidth. We're going to make it 15, we want our road to be kind of thick, and then we'll do pen.setColor. I want to change the color to QT, maybe dark gray. Okay, so now we've defined our create road, but we haven't actually used it anywhere. Oh, and before I forget, I create this QGraphicsLineItem, but I've not added it to a scene. Remember, what do you have to do to any QGraphics item before seeing it? You have to add it to the scene. So we'll do scene. And even before that, I want to set the pen of the line item. I made a nice little pen, but I'm not using it. So line item set pen, and we will set it to this nice pen that we just created. And then we're going to add item. What are we going to add is the line item. Okay, now it should be fine. Let's go inside the game constructor, and let's go ahead and actually call our create road. So we created our enemies here. Let's do create road, and we'll just call it right here. That's weird how it's not giving me auto suggestion. Oh, that's odd. Let's go inside the game class. Yeah, it's a public member called create road. It should be giving me autocomplete, but it's not, so I'm just going to copy and paste it so I don't make a spelling mistake. We're going to create a road. Okay, there we go. Now let's go ahead and run this, and hopefully it works, unless I made a silly mistake somewhere. Okay, there we go. Everything looks good. Now the road is actually being drawn. It follows the points to follow. The same list of points that these guys are following is actually being drawn. We can create our towers. There we go, along the road, and as the enemies pass by, they'll get shot. Oh, sorry. So there's like a bunch of different ways that you guys can improve this. A few things that I can think of is you can change the style. There's a lot of things you can change about this line to make it look better. You can look at the QGraphicsLineItem documentation to see what you can do with it. You can obviously have better graphics for the icons and towers, and you can have a little background. I showed you guys how to put a background in maybe tutorial 7 or 8 when I was making that top-down shooter. So you can do a lot to spice this up, but this has the fundamentals of a tower defense. You have the ability to build towers, and you have a little road, and you have enemies that move past that road. Now the damage system is very easy to implement. You simply give the enemies a health, and then you check for a collision between the bullet and the enemy. If so, you subtract from the enemy's health the amount of damage that that bullet does. Things like these are very easy to implement. So basically, this tutorial is running a little bit long. I'm trying to keep them a little bit shorter. I know that they've been getting kind of long. So basically, as an exercise, a few exercises for you guys. Try to give the towers a range. Right now, their bullets just keep going. So just try to give them a range. An easy way for me to just do this would be to give every tower a max range and a distance, or every bullet a max range and a distance traveled attribute. And then in its move command, just check if the distance traveled is greater than max range. If so, delete the arrow. So you can come up with your own implementation or just follow that. And then after you've done that, I would try to give the enemies a damage so that they can get damaged, and then maybe create a score label and a health label, and every time the enemies pass, your health goes down, and every time you kill them, your score goes up. Maybe you can implement a buying system where you actually have to pay for the towers. All these things, if you think about them for a second, they're not that difficult. This is all the fundamentals. So basically, I think we're done with the tower defense. I got a suggestion from one of the viewers to start a hex-based board game, which I think I might be doing either that or a top-down RPG kind of game. So anyways, let me know what you guys would like to see. Thank you for watching, and I'll see you guys in the next tutorial. Bye-bye.